Welcome viewers, in this video we will see the solved problem based on the open circuited impedance parameter, Z parameter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Open circuited impedance parameter, Z parameter, solved problem 2. The problem is find the Z parameter for the circuit shown below. So for this network, we need to find the Z parameters. So what are the Z parameters? Z11, V1 by I1 by making I2 equal to 0. That is open circuited. Open circuited means in this network, this is the input port A dash. This is the output port B dash. Current I1, voltage V1 at input port. Current I2, voltage V2 at the output port. So first we are making the output port is open circuited so that I2 equal to 0. By keeping I2 equal to 0, we can find Z11 and Z21. Z11 is nothing but open circuited input impedance V1 by I1, referring the input parameter. Z21 is the V2 by I1, output port voltage by input port current. So that it is a open circuited forward transfer impedance. Transfer between input and output. And another two parameter, we are making the input port is open circuited so that I1 equal to 0 for these two cases. For that we can find Z22, V2 by I2, open circuited output impedance, referring the output parameter V2 by I2. Z12 equal to V1 by I2, input port voltage divided by output port current. So this is the open circuited reverse transfer impedance. So these four parameter we need to find. For the first two parameter, we are making the output port is open circuited. So I2 is 0. For the remaining two parameter, we are making input port is open circuited. So the input current I1 equal to 0. So this is the network available. 1, 2, 3, 4 resistors are available. 1 ohm, this is 2 ohm, this is another 2 ohm and 4 ohm. So voltage V1, I1, V2, I2. So first we will find the parameters one by one. First we will find Z11, open circuited input impedance, Z11, V1 by I1, I2 equal to 0. What is I2 equal to 0? When I2 equal to 0 means V1 can be expressed in terms of I1 and the equivalent impedance of the circuit looking from the A dash terminal. So I2 equal to 0 means this port, output port is open circuited. We can refer from the input side, right? So V1 equal to voltage across the input port and I1 is the voltage in the current in the input port. So the V1 can be equal to I into R. That is V equal to I1 into Z impedance, Z equivalent of this circuit. We will see the after making A dash equal to open A dash by making B dash open circuit, we can see the equivalent circuit. So this is the equivalent circuit by making B dash is open circuited, right? So only A dash is considered. These four resistors are available. So in order to find the V1 equal to I1 into Z equivalent. So V1 equal to I1 into Z equivalent. So we need to find the Z equivalent of this circuit so that we can easily find V1 equal to I1 into Z equivalent. So Z equivalent is nothing but we are referring from this end, A dash. So while referring this end, what happened? This 1 ohm resistor is available. So here the current is divided so that these two branches are parallel. Same current is flowing through 4 ohm resistor. That means these two are in series. So these two are in series, that is parallel with this 2 ohm resistor. That is in series with the 1 ohm resistor, right? So 2 and 4 are connected in series. So 2 plus 4, 6. That 6 ohm is parallel with 2 ohm. So that is given here. For parallel combination, R1 into R2 divided by R1 plus R2. R1 is 2 ohm, this 2 ohm. R2 is 2 plus 4, 6 ohm divided by R1 plus R2, 2 plus 6. So this combination is in series with the 1 ohm. So 1 plus. So 1 plus this combination. 2 into 6 divided by 2 plus 6. So 1 plus 2 into 6, 12. 2 plus 6, 8. Right? So 12 by 8 is 1.5. So 1 plus 1.5 is 2.5 ohm. Right? So the Z equivalent of this circuit. From this Z equivalent, we can easily find V1 equal to I1 into Z equivalent. V equal to I into R. Z equivalent is 2.5. Now brought this I1 in the denominator. V1 by I1 equal to 2.5. This V1 by I1 is nothing but Z11. This Z11. Z11 is nothing but V1 by I1 by making I2 equal to 0. So that V1 by I1 is replaced as Z11, that is equal to V1 by I1, that is nothing but 2.5. So that Z11 equal to 2.5 ohm. Right? So this open circuit input impedance is calculated by making the output port current 0. In order to find the V1 equal to I1 into Z equivalent, we are calculating the Z equivalent of this circuit referring from AA dash. From that easily we can calculate the Z11, that is 2.5 ohm. Now we can find the Z21 for the same circuit. The same circuit we need to find Z21 by referring the output side. Now refer this circuit. Z21 equal to V2 by I1 by making I2 equal to 0. So what is V2? V2 is the voltage across 4 ohm impedance. So this is a 4 ohm. This is the original circuit. This output port is open circuited. We need to find V2. V2 is nothing but voltage across this 4 ohm resistor. How will you find the voltage across this 4 ohm resistor? V equal to I into R. So we need to find the current flowing through this 4 ohm resistor. R is nothing but 4 ohm. Right? So V2 equal to Ix into 4. V equal to I into R. R is 4 ohm. Ix. Ix is the current flowing through this 4 ohm resistor. This Ix. This I2 is already 0. So our aim is we need to find the current flowing through this 4 ohm resistor. Now refer this. This is a V1. Current I1 is flowing. Input port current. Current is divided here. At this point current is divided. Current is divided to 2 ohm resistor. Another current is divided to this 2 ohm and 4 ohm are connected in series. So 6 ohm resistor. The balance current will flow through 6 ohm resistor. So one branch is 2 ohm resistor, another branch is 6 ohm resistor. So by using the current divider rule, we can easily find the current. Where let us consider this is Ix. Current flowing through this branch is Ix. We need the current flowing through this branch only, not this branch. So that we are making Ix. So I1 is the total current, Ix is the current flowing through this branch. This is the what we need. So Ix equal to, what is the current divider rule? This is the branch current equal to total current I1 multiplied by other branch resistor. What we need the current through this branch. But here numerator what we have, other branch resistor 2 divided by total resistor. 2 plus 4, 6. So 2 plus 6. Right? In voltage divider rule, branch voltage equal to total voltage multiplied by branch resistor divided by total resistor. Same branch resistor. Where we need the voltage, that resistor is multiplied. But in current divider rule, it is opposite. Right? We want the current through this branch, mean it is multiplied by other branch resistor. 2 divided by total resistor. So I1 equal to 2 divided by 8. So that is nothing but 2 divided by 8 is 1 by 4. So I1 by 4. So Ix equal to I1 by 4. Current flowing through this 4 ohm resistor is I1 by 4. Now we'll go to this. V2 equal to Ix into 4. V equal to I into R. R is 4 ohm. I is Ix. Ix what we calculated? I1 by 4. This 4 got cancelled. I1. V2 equal to I1. Brought this I1 in the denominator. So V2 by I1 equal to 1. So this V2 by I1 is nothing but Z21. Open circuited forward transfer impedance. That is equal to 1 ohm. Right? So Z21 we calculated 1 ohm. Right? By using the current divider rule, current is calculated from the current, the impedance is calculated. So the one part is over. By keeping the output port is open circuited, we calculated Z11 open circuit input impedance and Z21 open circuit forward transfer impedance. Now we will go to the next part by making the A dash is open circuited, so that we can able to find the remaining two impedance parameters. When the port A dash is open circuited, the voltage at the port B dash can be expressed in terms of I2. So while making the port A dash is open circuited, automatically I1 is 0. So we need to express in terms of I2. And the equivalent impedance of the circuit is viewed from B dash. Here we viewed from A dash. Now we need to go with B dash. I1 is 0, I2 is calculated, and the impedance calculated from B dash. Now we'll go to the next step. We'll see the what is the equivalent circuit while making A dash is open circuited. So now we'll find the remaining two impedance parameter. First we'll find Z12 V1 by I2 by making I1 equal to 0. V1 is the voltage across 2 ohm impedance, and let the current in 2 ohm impedance is IY as shown in the below. So I1 is 0, V1 by I2. So we need to find the V1, voltage V1 we need to find. By referring this diagram, this input port is open circuited. This output port, the voltage is V2, B dash, the voltage is V2. What is V1? We need to find V1. Then only we can find Z12. V1 is the voltage across 2 ohm resistor. So V equal to I into R. I is current flowing through this 2 ohm resistor, IY into R is 2 ohm resistor, right? So V1 equal to IY into 2. So now we need to find the IY, current flowing through this 2 ohm resistor. Current will not flow through this 1 ohm resistor because of open circuit. Again here we are following the current divider rule. Here I2 current is there. This current is divided at this branch. Part of current is flowing through 4 ohm resistor. Remaining current will flow through this branch 2 plus 2. They are connected in series. So 2 plus 2 4 ohm resistor. One 4 ohm, another branch also 4 ohm. So we can apply the current divider rule. IY branch current equal to total current multiplied by other branch resistor. So this is the other branch resistor 4 ohm. So what we need is this branch resistor, but it is this 4 ohm resistor. We can write like this: 4 divided by total resistor 2 plus 2 plus 4. So the current divider rule opposite. What we need is branch current through this 2 plus 2 4 ohm. So it is multiplied by numerator multiplied by other branch resistor 4 divided by 2 plus 4. So 4 divided by 8, that is nothing but 1 divided by 2. So IY equal to I2 divided by 2. So now we calculated I2, IY, current flowing through the 2 ohm resistor. So V1 equal to I1 into 2 based on the formula V equal to I into R. But IY is I2 by 2. This 2 got cancelled. So V1 equal to I2. Brought this I2 in the denominator, this side, V1 by I2, that is equal to 1. V1 by I2 is nothing but Z12. So Z12 equal to 1 ohm. So the open circuit reverse transfer impedance Z12 is 1 ohm. So earlier Z21 also 1 ohm. This Z12 also we got 1 ohm. So now we got one more parameter Z22. We'll see the Z22. So the another equivalent circuit is available. So this input port is open circuited. We need to find the output port voltage V2. What is Z22 is nothing but V2 by I2. V2 by I2. V2 equal to I2 into Z equivalent. We need to find the Z equivalent of this circuit so that we can easily calculate the Z22. What is Z equivalent? We need to refer from B dash. Already A dash is open circuited. So we need to refer from B dash. So what is that? So at this point the current is divided. So this 1 ohm is not taken into account because of open circuit. Current will not flow through this. So current is divided mean these two are in parallel. This 4 ohm is parallel with this branch. These are connected in series, 2 plus 2, 4. So this 4 ohm is parallel with this 4 ohm, right? The current will not go here. So 4 ohm resistor and 2 plus 4 ohm resistor both are in parallel. So Z equivalent equal to 4 into 4 divided by 4 plus 4. R1 into R2 divided by R1 plus R2. 4 into 4 16 divided by 4 plus 4 8. So 16 by 8 2 ohm. Z equivalent equal to 2 ohm. So V2 equal to I2 into Z equivalent. V2 equal to I2 into Z equivalent is 2 ohm. So brought this I2 in the denominator, this side. V2 by I2 equal to 2. So V2 by I2 is nothing but Z22, open circuit output impedance, that is 2 ohm. Now we calculated all the 4 parameters, Z11, Z21, Z12, Z22, right? All 4 impedance parameters are calculated. So we can go for the general equation and general conclusion. Here Z12 is equal to Z21, both are 1 ohm, what we calculated, which indicate the bilateral property of the network. Because both are equal, this is a bilateral property. The describing equation for this two-port network in terms of impedance. I will write the impedance, the generalized equation, right? So because of both are equal, it is a bilateral property. The given network is bilateral. The general equation is V1 equal to Z11 into I1 plus Z12 into I2. Similarly, V2 equal to Z21 I1 plus Z22 into I2. So V1 equal to Z11 is 2.5 ohm into I1 plus Z12 is 1 ohm, so into I2. And V2 equal to Z21 is 1 ohm, so into plus I1 plus Z22 is 2 ohm, 2 I2. So V1 equal to 2.5 I1 plus I2, V2 equal to I1 plus 2 I2. So this is the generalized equation. So in this problem we calculated the Z parameter for the given network. 4 impedance parameters are we calculated. For that, first two parameter calculated by making output port is open circuited. Remaining two calculated by making input port is open circuited. And we concluded that this network is bilateral because both are equal, transfer impedance are equal. And also we framed the general equation, general impedance equation for the network. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.